Our objective for today, I can solve and graph quadratic equations. Read together, 1, 2, 3. I can solve and graph quadratic equations. So we're moving on. We already covered quadratic functions last week. Today we're starting with quadratic equations. It's going to go a little bit fast, so make sure you keep up. And in our Ferrier model, what are quadratic equations? It's very similar to functions. So quadratic equations are two-variable equations where the highest degree is 2. Quadratic equations, two-variable equations where the highest degree is 2. Two-variable equations where the highest degree is 2. Two-variable equations where the highest degree is 2. Quadratic equations, two-variable equations where the highest degree is 2. Quadratic equations, two-variable equations where the highest degree is 2. 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 So you know the definition, please? Thank you. Examples. Write those down. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. Y minus 6 equals 3x squared plus 11x. Non-examples. X squared, and then we got x squared plus 3x plus 2, negative 3 plus x equals 10. Copy that, please. All right, let's see. Two variable equations. Do we have two variable equations here? Yes, x and y, x and y, x and y. Highest degree 2. Yep. So, tell your neighbor why these three are not quadratic equations. Okay. Let's see, Francisco. Why is this one not a quadratic equation? Okay. Hands if you agree with that excuse. Look at this one. Well, we're excusing this one from being a quadratic equation, and we say that because it's not, it doesn't have another variable. Well, let me do this then. Hold on. Let me do this. So, Francisco, why is that not a quadratic equation? Not an equation. All right. How about this one, Francisco? Oh, sorry. Okay. How about this one? Very good. So therefore, it needs to be an equation and the highest degree 2. Thank you. Now, today I tried to crunch as much as I could the steps for today's lesson. So I crunched it down to about 7. So it's only 7 steps. Only 7. So copy this, please. Step 1, solve for y. Set in standard form. Step 2, substitute 0 for y. Step 3, factor the trinomial. Step 4, set each factor equal to 0. Step 5, solve for the variable. Step 6, graph using the x-intercept and the y-intercept. Step 7, check. And this is a process. What we do today is the way I want the home plate. And once again, I know the books do not ask you to do certain things, but I do want you to do this process tonight. Okay? Copy that, please. So we got this, right? So now, I'm not going to have you guys, like, really think about these steps right now. We're going to go through the process, and with the process, you're going to be able to memorize these steps. But let's look at each individual step to see if we know how to do some of these things already. Do we know how to solve for y when given an equation? Yes, just isolating y, right? Do we know how to substitute for 0? Do we know substitution? Yes. Do we know how to factor? Yes. These two steps is something that we're going to look at. Do we know how to graph if I was to give you the x and y intercepts? Yes. And do we know how to check to see if a point is part of an equation? Yes, we know how to do all those things. So today we're going to crunch everything together. So since we need plenty of room for this, and if you write with 50 font or whatever, you need the back side. Copy this in the back side, please. Example 1 says, solve the quadratic equation by factoring and check your answer. Solve the quadratic equation by factoring and check your answer. The equation is x squared plus 8 equals y plus 6x. Copy that. Solve the quadratic equation by factoring and check your answer. So notice it doesn't say anything about graphing, does it? No, but like I said, I want that in the process, and I'm going to show you how in a little bit. Here we go. So step 1 says solve for y. Look at it. So usually, just to keep myself organized, I draw my line down the equal sign. Where's my y? It's on the right side. Everyone, what do? Subtract 6x, subtract 6x. However, look up, please. Writing utensils down. In this case, notice here I cannot combine x squared with 6x. Is that correct? Or 8 with negative 6x because they're totally different terms. But I did write it in standard form. Is that correct? So what goes first? Minus 6x plus 8 and all that equal to y. Okay, copy that. Step 2 says what, Idalis? Substitute 0 for y. So y, instead of y, I'm going to substitute 0. I bring everything else down, x squared minus 6x plus 8. However, let me elaborate on this part. Look up, please. Why is it that I'm doing this? Let me show you why. Pens down, look up, please. Writing utensils down. Remember back when we were on, when we barely started with two variable equations that I gave you stuff like this, 4x plus 2y equals 8. And then I said, let's use the cover-up method. Who remembers that? Cover-up method, right? So check this out. If I was to cover up the y, what do I have left? 4x equals 8, and I solve. Is that correct? Well, basically, the cover-up method is this. Substituting instead of y, if I substitute 0 for y, what is 2 times 0? 0, so I'm left with 4x equals 8. And then I solve. It's the same thing. The cover-up method is the same thing as substituting 0 for y. And what am I doing here? I'm finding my x-intercept and I'm finding my y-intercept. Is that correct? So if I substitute 0 for y, when I solve this, what am I going to find at the end? Yes, my solutions. But what are they called according to what I just explained over here? The what? Okay, I substitute for y, I substitute 0, and I only have x's. So if I was to solve this, what am I going to end up with? X-intercepts. Does everyone understand that? That's why this step is key. You need to make sure you substitute 0 for y. That was the y part as to why we substitute for y for 0. For those of you that were paying attention. Some of you are still like, your brain is somewhere else. Come back, please. Step 3, it says factor the trinomial. Look up to the screen. If I was to cover up this part, doesn't this look familiar? Do we know how to factor that? Yes. So I'm just going to uncover this so we can get used to how it looks. So to factor this, I need to check for GCF. Is there GCF on that? No. Power units, We got 8, negative 6. What factors of 8 give me the sum of negative 6? Negative 2 and negative 4. That is correct. So we rewrite this. We rewrite x squared. What else? Negative 2x. What else? Negative 4x. What else? Plus 8 equals 0. Copy that, please. All right, let's continue. Do we know what to do from there? Yeah, we group these two, and these two. What's the GCF for these first two? X, and we're left with x minus 2. GCF for the last two, negative 4. We're left with x minus 2. Therefore, my factors are x minus 2 times x minus 4 equal to 0. We're still not there. We're almost there. All right. So, once again, let's go through the process. Step 1, solve for y. Step 2, substitute 0 for y. Tell your neighbor why we substitute 0 for y. Okay? Everybody hear that? Everybody said cover up? You're like, I don't know what that means, but I just said cover up because somebody else said cover up. Yes, because we use the cover up method, but because we need to solve for our X-intercepts. Next, factor the trinomial. Did we know how to do that? Yes. Now let me show you the next step. The next step says write each factor equal to 0. But before I do that, let me show you the why we do that. At the beginning of the year, I showed you a property that said any number times 0 equals 0. And that was called the zero product property, ZPP, zero product property. So any number times 0 is 0. So how about 0 times b? What is that? But what if I gave you this? Don't say it out loud. A times b equals 0. Now we encounter a dilemma, right? However, what could A be? Or what could B be? So either one or the other could be 0, right? Well, look at this step right here. These two are multiplying, aren't they? Aren't these two multiplying? So this is saying that this times this equals 0. Therefore, because our zero product property, x minus 2 could be 0, or x minus 4 could be 0. Does everyone understand that now? I'm sorry? We're still not done. Okay, let's solve the equations. What do I do here, everyone? Add 2, x equals 2, add 4, x equals 4. Therefore, these are my solutions, also known as X-intercepts, also known as roots. And when you get to algebra 2, they're going to start calling them zeros. And why do you think they call them zeros? Because of the zero product property, because one or the other could be what? Zeros. Thank you, Mr. Yu. Good. We'll get there. Give me a second. All right. Everybody copy that already? All right, so let me go again to recap all the steps. Step 1, solve for y. Step 2, substitute 0 for y because of our cover-up method, yes. Step 3, factor the trinomial. Step 4, set each factor equal to 0. Which property makes me do that? Zero product property, very good. Man, is everybody okay? You guys have too many corn dogs over the weekend? So, it was Monday. Bam, Sergio, extra credit. All right, so then we solve each equation. X equals 2, x equals 4. These are my solutions. So if they ask you to solve a quadratic equation, these are your solutions. What's another name for the solutions? My x-intercepts. What's another name for that? Roots. What's another name for that in Algebra 2? Zeros. Everybody got it so far? All right, so now that we have our solutions, so check this out. Now we're going to graph. Look up, please. So to graph, I create my little coordinate plane. And like Sergio said, well, how can we find our y-intercept? Okay. Remember cover-up method? We cover up the y. Y became what? And we find our x-intercepts, right? So now we cover up what? The x. And what do you see? 8. So my y-intercept is 8. Boss in the house? Okay. To get our x-intercepts, we use the cover-up method, or we substitute 0 for y. Is that correct? And that's how we got our x-intercepts. But now we need to find our y-intercept. So if we use the cover-up method, instead of covering up y, what do we cover up? So if we cover up x, what do you have left? The 8. So our y-intercept, that's where we start our graphing, is at 8. Wait. Both what? Okay, those are two x-intercepts. But for y, how many y's did you see? 1. So it's only one y-intercept, 2 x-intercepts. We got x equals 2 and x equals 4. I'm sorry? You have to plot all 3 points. You have to plot 3 points. So check this out. And then we start from left to right. And we know it's a parabola, right? So look at the original equation, this one, the second equation. What is the coefficient here? And it's a positive, right? So what did we say with parabolas that had positive coefficients? That it was opening. Very good. My goodness. Opening up. Copy that, please. You can go further down if you want. My tablet's not giving me a lot of pixels there. So for right now, it doesn't matter as long as you go back up on the second x-intercept. Okay? And this is our parabola for this. That's our graph. Let's check. For the check, let's use this equation. Look up the second one once it's solved for y. So we have x squared minus 6x plus 8 equals y. Which were our solutions, we said? 2 and 4. So I'm going to check to see if 2 is a solution. I need the point, which is 2, 0. And I'm also going to check if 4 is a solution. What is that point? 4, 0. I'm going to check 2 and 0. So instead of x, it's 2 squared minus 6 times 2 plus 8. And instead of y, what goes there? 0. So this is 4 minus 12 plus 8 equals 0. Combine like terms. That's 12 minus 12 equals 0. What is 12 minus 12? 0 equals 0. Did it work? Yes. On this one? Yeah, you can use this one also. Because this is the same one, right? But I just like this one because this one already has the x's together and everything on one side. And let's just use the original one for boss's sake. X squared plus 8 equals y plus 6x. But instead of x, now I'm going to check what? 4. 4 squared plus 8 equals 0 plus 6 times 4. So 4 squared is 16 plus 8. 0 plus 24. 16 plus 8 is 24. Is 24 equals to 24? Yep. Yeah. Okay, we do 2 checks. Everybody say thank you, Edgar. I was about to say that I checked the first one, and we know what pretty much we're going to get on the second one, right? But just for today's sake, thank you, Edgar, we'll check both. So let's go over again through our process. Step 1, solve for y. Step 2, substitute 0 for y. Why? Because that's usually using the cover-up method, yes? That's how we find our x-intercepts, by factoring the trinomial. And at the end, we find our solutions, x-intercepts, roots, and zeros. From there, we need our y-intercept, which was the constant. If everybody see that? And who remembers? Let's see. Look up, please. For the warm-up, didn't I give you something like this? Negative 2x plus 7. What is my y-intercept? Why? Because it doesn't have any x multiplying that number. It's a constant. So look at this equation. What was our y-intercept? Same thing, the constant. Are we doing? All right? Okay, example 2. Yeah, we finished example 1. Yay. I only have 10 examples, so here we go. Don't copy the verbatim, just copy the equation. Y minus 7x equals x squared plus 10. So let's do this one together and go a little bit faster. Step 1, solve for y. What do I do, everyone? Very good. Add 7x, add 7x. Y equals standard form, which is x squared plus 7x plus 10. So far, so good? Next step, everyone. Y equal to 0, or substitute 0 for y. 0 equals x squared plus 7x plus 10. What do I do from there? Factor. Is there a GCF? No. Power rangers. We got 10 and 7. Factors are 2 and 5. We rewrite this. This is x squared plus 10. No. No. Didn't I explain this already? Okay. Thank you for asking. But no. Remember, what is the one thing that we need to practice so that when we get to algebra 2? But for factoring, it's called what? Factoring by what? By grouping. By grouping. There's going to be some parties that I'm going to have you do, like block parties. They're coming up. And I'm going to allow you guys to do shortcuts. And that's fine. So let's group these 2 and these 2. So what is our GCF for these 2? X. We're left with x plus 2. GCF for these 2 is 5. And then we're left with x plus 2. All that equal to 0. Therefore, our new equation is 0 equals x plus 2 times x plus 5. What do I do from there? Julian. X plus 2 equals 0. X plus 5 equals 0. Thank you, Julia. Oh, this step? Okay, everybody look up. There was a question by someone over here in the front. I'm not going to say names. They were saying, what's the point, Mr. Q, of doing this extra step and then subtracting 2 and writing x equals negative 2 and subtracting 5 and writing x equals negative 5 if we can just do the opposite of what we see there? Well, what if we get factors that look like this? Then what do we need to do? Then you need to do solve the equation, right? That's why I need you guys to practice your steps. I want to see the work. So these are called my X-Intercepts, my solutions, my zeros, or my roots. The roots are, all right, let's graph this. All right, tell your neighbor the y-intercept, please. Very good, 10. And my x-intercepts are -2 and -5. And we're going to go from left to right, point to point. So we start up here because it's a parabola. Go down, through the other, through the y, and we're done. Yes? Okay. All right, so for time's sake, let's go to the next one. You can check later. I was with you guys on this one, so I know it's right. Example 3, yes. Did you ever hear that one? Look up. Voss said, can you just multiply the x solutions to get the y-intercept? Guys, wait. Now, who remembers we did stuff like this? Look up. And that's how we get that, right? So, yeah, thank you, boss. Very good. So, for home plate tonight, it's page 577. Only that page for tonight. Once again, there's tutoring tonight. Give me your assigned progress by tomorrow. Assigned parte. Have a good one. Enjoy your home plate. See you guys tamales.